Hello, and welcome to Coffee and Compliance, where we connect with experts on various compliance and security topics. I'm Allan Reyes, Security Engineer at Vanta, and today we'll chat with Shawn Miller, Senior Community Engineering Manager at Snyk, to demystify vulnerability scanning for your business. Okay, so to top things off, we're going to talk about the what, why, how, and when of vulnerability scanning. So let's set the table first. Shawn, what is vulnerability scanning?
Yeah, it's basically just having a set of processes and tools that are looking at your applications and potentially infrastructure or cloud, trying to find vulnerabilities and risks that your applications are bringing.
Awesome. Tell me more about where Snyk fits into this.
So where we fit in is we're essentially a developer first company where we're trying to help your developers find vulnerabilities in the application as they are building it. And there's many different types of security checks, and we'll get into that and presumably as we progress through this. But it's all about empowering the developers to find that as they are building, but not just find the issues, but actually fix it. And it's all about reducing your risk because finding those issues is not the same as fixing it. And that's essentially where Snyk fits in.
I love that. Can you unpack that more about how reduce or finding issues is not just reducing risk and fixing is?
Yeah, so to give you an example, so let's say you had an application, you've been working on it for a few months, you go and you scan it and you find 10,000 issues. Now imagine taking that list to your developers and saying, hey, can you go and fix this? And meanwhile, you have the application that's live out there today, and it's going to take days, weeks, months to fix all of those issues. And there's going to be a huge amount of time spent investigating it. So you not only have the time that it takes to actually get it fixed, but you may have a whole set of issues that are not fixed either because it's determined they don't want to fix it, or it may fundamentally change the application. And then you also have the added issue of, because testing was left so late, when you find an issue, you're not just going to find one, you're probably going to find dozens or hundreds. And so imagine if you were building the application and you could be told, hey, you found a vulnerability after you wrote the single line of code. How likely is it that you're going to reproduce that issue as you're writing that application? So you do it once, you get corrected, you're not going to repeat it. Now, when you go start a new application, you're probably less likely to repeat it, and so on and so on. So you're reducing your overall risk by enabling that development team to find it very early on, fix it right away, and then through a combination of tool and education, you're reducing your overall risk, because the reality is you're building that application more securely out of the gate. And I'll probably talk about this quite a bit as we go through this,
Sure.
but it's not just about being reactive, having a security tool doing the testing, but it's part education, providing education around secure coding, providing tools that help them figure out what open source packages are better from a security standpoint, or more amenable towards like the types of licenses that it uses, or for example, when they're writing the code, are they given guidance around, maybe this line of code wasn't written from a secure standpoint, and doing that while they're working on it, as opposed to being a policing action later on where you get this giant report and you get continually pitted in that triage process of
Yeah.
find an issue, investigate it, prove to the development team you need to fix it, and so on. And that essentially, at the end of the day, that's why the industry has really shifted more. Like we talk a lot about shift left
Yep.
and DevOps and DevSecOps and so on.
Yeah, wonderful. Yeah, I'd love to dive into shift left, as well as this vulnerability management, and like the topic for today that we're discussing is just vulnerability scanning, right? And that is just like one small piece, important piece of the whole vulnerability management process or pipeline, right? Any high level comments there or questions about vulnerability management?
Yeah, so I think again, like when we talk about compliance at the end of the day is about having a set of controls, a set of checkpoints
Yeah.
saying you're going to be doing this type of testing. When you do find a vulnerability, you're going to go and fix it. And I think it's really, really important that we go beyond that. Again, not just being reactive or having a scanner. It's something where you want to make sure that security is a part of the development process. And
Yes.
at the end of the day, security is just good business. And you're going like you're hearing a lot more in industry now about things like S bombs or supply chain security, or companies performing pen tests on applications before they acquire it and so on. And so companies are looking for proof that when people are building software, that it is something they're being provided something that's secure. And so big part of that is making sure you have the tools and processes in place to actually do that analysis. But going beyond that, making it a part of your culture, making it a part of the DNA of when you go to build an application. So it can't just be, I have a scanner and I'm just doing it at the end of development. It has to be embedded throughout that development process. But again, it's not just the scanner, it's everything around it, training your developers around secure coding, providing those guidelines, trying to embed security as part of that development process, and not acting so much as a policing factor or a checkpoint, but more as an enablement feature. And that's going to help you build applications faster. It's going to be a heck of a lot cheaper because, again, you're not going to be reproducing the same issue over and over. You find it once and then you're going to move on, and you're not going to have to continually fix or play whack-a-mole with vulnerabilities because, again, it's an ingrained part of that development process.
Yeah, 100%. Definitely agree. I think an important point for the audience is that, vulnerability scanning, it's not just an island, right? There's inputs and outputs, and it has a very special place in the whole pipeline, right? And like, if you think about things that should happen upstream, right? Things like asset inventory, knowing the things that you have, so that you can actually point your scanners and your tools towards it. I think that's a often misstep. Also, the notion of asset discovery, and this notion of like shadow IT, and you can't find a or scan or find the vulnerabilities for the assets that you don't know about, right? And so I think upstream, there's lots of very important inputs that go into the scanning portion, and then the outputs, downstream, like, okay, you found a bunch of vulnerabilities, now what, right? And that naturally leads into things like reporting, and then eventually remediation, and then circling back to detection and seeing, okay, let's scan it again and see if we still have it or if we actually fixed it. Yeah. Very exciting stuff. I think if we talked about just vulnerability management, we could record like 10 webinars for this. But let's zoom back into the vulnerability scanning portion. So I think a good segue here is to talk about the different types of scanning that we can conduct. Could you maybe break down a few of these for me?
Yeah, so let's start first with the very high level. So when you think about an application, it's evolved quite a bit over the years. So in the old days, developers were writing an application, so all of the code was there. But over time, you started introducing concepts like open source. So the developers are not only writing the IP, the logic of their applications, they're including third-party code as a fundamental part of that. That's everything from the UI to how it interacts with the backend. So that you have not only the first party code, you have your open source, and that the neat thing about open source is that today there might be no known vulnerabilities, but then tomorrow you might have 50 new vulnerabilities related to that package. Then you have the fact that those applications no longer live in isolation. They're now being deployed to cloud. And so with cloud, there becomes a further set of problems. So in the old days, infrastructure was really an IT or an infrastructure team problem. Now development can make fundamental decisions that impact that. So you have concepts like infrastructure as code. So when a developer builds what's called a container, which is at the end of the day, it's just basically a way to deploy your application. They're writing files saying how to deploy it, either as a container or maybe up to the cloud, like AWS, Azure, and so on. And so you now have infrastructure as code files that may have misconfigurations. Maybe there's items in it that are misconfigured, or worse, maybe there's some critical security items that aren't being included in that. That's going to lead to basically your application being insecure because where it's being deployed isn't configured in a secure way. And then the containers themselves, those need to be tested. And if you're not familiar with a container, you can kind of think of it like a box, and it's essentially a file system. You have, taking an example, you're going to have your Linux packages. So the most basic layer. On top of that, you're going to have an application that's running, and it's going to rely on open source dependencies. And the idea there is that each one of those layers could potentially have a vulnerability, and then that's being deployed to something like Kubernetes or OpenShift, or basically, again, to the cloud. That is going to have its own set of vulnerabilities, not only in how it runs, but where it runs, and the permissions that it's given. And so you have all these different layers that development has input on, and we need the ability to test it. And I can go through all the techniques and maybe some of the pros and cons on that. But essentially, it's just the different layers of what the developers are building. And then, of course, you need to test the infrastructure and cloud around that as well.
Yeah, I love that. The modern software stack, there's just so much software and so many different layers, and vulnerabilities can really crop up on each
Yeah,
of these layers, right? And very often through open source, and many times through first part or code that you write, first party code, right?
absolutely.
Um, okay, let's maybe dive into a couple of these layers, right? So you mentioned, containers and scanning the vulnerabilities there, like, kernel vulnerabilities and stuff like that. What about on the application tier, right? So say you're a company and you're writing your web app in like Node.js or Ruby or any of these languages. Like, how can vulnerabilities get introduced there, and like how do you scan them?
Yeah. So again, like as the developer is writing their code, let's take an example. Let's say you have a login form, right? So
Hmm.
you have a login form, you're going to put in a username and a password. When the user clicks the button, it's going to go up to the server. And then somewhere in that logic, that data that you typed in is going to be queried against the database. And so what you need is essentially a tool that will look at how that data flows, and did you take that data from the user and do something insecure with it? And so the first thing is using what's called SAST, so static analysis, to try to find that vulnerability. Now, in that code that you wrote, you might actually be using a third-party library, not only for the UI, so the interface, saying, here's how to display the form and here's all the fancy widgets. You might even have open source in the back that says, here's how to interact with the database or the back end to do that querying. Well, as a developer, if I'm writing code, I have what's called a package JSON. It's basically saying, hey, I want to include this third-party library like Express or React or Vue or whatever third-party piece I'm using. And that library is bringing in other packages, which is bringing in other packages and so on. So with a single line, I could be bringing in a million lines of
Yeah,
code. And that's a little bit of hyperbole, but it could be 10,000 lines. Or the
right.
idea is a single line could be just bringing in a whole chain of stuff. And so you not only need to be able to say, hey, I am using this package with this version, you then need to figure out, here are all the other packages and here are all the other versions. And again, going back to what I mentioned earlier, today, none of those packages may have any known issues.
Hmm.
So you need the ability to not only identify the packages and the versions, but you need to continually retest that on a regular basis, because researchers are always checking and disclosing new vulnerabilities. You might be familiar with the term CVE. Basically, it's just an identifier saying, here's a vulnerability. Researchers identify these new vulnerabilities, they number them, and it's easy to find. And so you want to have a tool that's checking those libraries or packages, identifying, are there any known issues related to them, and it has to be done on a continuous basis. Whereas your first party code, you test it once, it's not as likely, like it can happen, but you may find newer issues as the tools get better or as you evolve your code base. So applying static analysis on your first party code, applying what's called SCA, or basically like your supply chain testing of what open source dependencies you're using. And then you also have other things like the IAC testing, infrastructure as code,
Hmm.
and then of course the container testing. And again, like as you build that application, you're probably building it as part of a container. So you probably heard the term like microservices, or it's just a fundamental way that people build things for cloud today. What's interesting there is that when you go to build your application, the developers can now say, okay, I'm going to build this box that I want to deploy that application with. And in that box, here are all the open source packages I need. Here are the Linux packages that need to be installed in that, as an example. And that's great. But these developers are not building these containers from scratch. Well, I mean, they can, but they're usually building a container off another container, like
Yeah.
a building block. So it's interesting that we did a study, I think about a year ago on this, where the most popular containers being used by people today had hundreds, thousands of issues, and everybody was using them. And so it's critical that when you build your containers, which again you're often doing as you're building your application, or you might have a DevOps team that's setting these up for you, it's not just about getting a list of 500 issues. You want something that recognizes how a developer builds it. So often you'll have like a Docker file. It just has a line there saying, hey, I'm building this container off, say, this image of Node or Python, and it's using this version. Well, when you go to scan it, you want to be able to say, well, oh, you're using this container. Well, there's a better version of that container, or maybe there's a different flavor of that container. So with one change, you might be addressing hundreds of issues. And then you might have maybe 2 or 3 issues that your layer introduced, so the instructions that you were adding. And so it's not just about getting that giant list of issues, it's about providing strategies to help you deal with the issues the way that the developers are building it. And so that's kind of why at the beginning I mentioned about finding the issues is not going to reduce your risk, helping them fix it, but it's also the fix strategies around it. I could give you 500 issues with 500 fixes, but if I can give you a strategy with one fix, you might, even with open source, one fix could potentially address hundreds or thousands of it, dozens of issues.
Maybe.
I always think the worst case, but like, again, like with containers, you see that quite often where a single version number could potentially introduce 50 issues or fix them. And so that scanning is critical at all the different layers.
Yeah, beautiful. I love it. Yeah, and sometimes the solution is to, okay, instead of fixing it, let's just remove this dependency, right? And I think that's a totally valid strategy where you just like minimize the amount of layers or the amount of dependencies and transitive dependencies that get pulled in, right?
And I can throw one little twist to that as well. Is so imagine as a developer, you're writing your application and you're building it as part of a container. You write your infrastructure as code saying, hey, I want to deploy this container up to the cloud with these settings. Maybe I turn off all the special privileges and, here are the ports I want to deploy it to. And so it's all codified. It's great. That means we have a repeatable process. Like that's the beauty of infrastructure as code. Then something happens and somebody on the support team goes up to AWS and makes a change, or a developer had to get something out really quick and they push something up to the cloud. And so now you have something disjoint from here's what we have codified in our infrastructure as code, but here's what's out in production. And so you end up with a disconnect of here's what we've codified and built, and now here's what's out in live. And that's where you start blurring the lines of I just have an application. You have a whole pipeline, a whole ecosystem of things. And that's why you're starting to hear more about CSPM, so like cloud security, posture management, and so on, because you also need to understand what are the assets I have out there, what are the configurations, which again all stem from that infrastructure as code and cloud methodologies that you're using to build and deploy those applications.
Great, I love that. Okay, so to recap this section, we were talking about the different types of vulnerability scanning, or what are the different types. So some key takeaways here: software has a bunch of different layers, right? There are a lot of different tools that you can use to scan different parts of those layers. Oftentimes these layers pull in a lot of open source dependencies, and then those dependencies themselves can pull in other dependencies or transitive dependencies. So very large surface area. And just zooming back, scanning is not just the end, right? Like it has to be tied to some type of strategy to ultimately remediate or remove these vulnerabilities. Excellent. Okay, so let's take a pivot and let's talk about let's zoom back out and talk about why vulnerability scanning is important. And I remember we mentioned earlier, we talked about shift left. I'd love to talk about that and how that fits into answering this question.
Yeah, so I think, if I were going to summarize it, probably, I think I've mentioned a few of these points, but I'll re-summarize it. So I think one is it helps reduce costs, right? So you're finding it earlier, you're not reproducing, you're not reproducing it over and over. You're not changing your development schedules to try to get something that, you could have been found earlier. So cost reduction is a big part of that. Risk reduction is a big part of that. I think stress levels and building a better application and the relationships between security and development are really helped here, because again, you're no longer acting as a policing function. It's all about enablement and enabling that development team. And I don't think I mentioned this earlier, but one of the benefits of shifting left is you're now going from a very small security team of, say, 5-10 security people in your company. And, if you're a startup, you might even have one or none. But by enabling that development team to do that testing as they are building the application, you've now fundamentally scaled out your security team. You have more people being part of the solution as opposed to being seen as part of the problem. And so that enables the security team to become more of an advisory role, or to focus on the things that are more difficult or maybe need more eyes on it, or more sophisticated analysis to be applied to that. Because again, tools get you to a certain point, but then you get into pen testing and more thorough analysis as well. So shifting left is all about build it in as part of your development process, test it as early as possible. And
Yes.
Again, that's about putting it, empowering that developer. And, I'm using marketing words here, but
Sure,
it's
that's fine.
give the developer tools, but educate them, provide them secure code training, give them tools that help them make the right decisions, whether it's picking the packages or writing the code, building the guardrails, which might be when they do a pull request, it'll have it automatically check like, hey, is this code secure? And then asking them like, hey, I need you to go back, make these changes, commit it, and then we'll allow it to progress in the code pipeline. And then when you go to deploy it, having checks and balances there that might prevent that deploy. And so when we talk about shift left, again, it's not just about a scanner in that development process. It's about facilitating all those different steps. And different companies are different. Like some companies are moving so fast, they have the perception where they don't want the developers to do that because they're really busy. But if you could make it seamless in what they're doing, so they're already working in an IDE, like a development environment. What if I write a line of code and I can click a button, and then in a few seconds I get very accurate results? They're more likely to fix it as opposed to getting a giant list at the end after a week of development. Like, and again, they're not going to repeat the same mistake over and over. So.
Yeah, definitely agree. The way I like to think about shift left is that we're pushing a lot of these tooling and processes, and most importantly, feedback cycles closer to the developer, and that ends up being much quicker, much more effective. And you mentioned cost. It is much more cost effective than finding a vulnerability much further downstream when it's already deployed to production, right?
In my career, I've heard everything from 60 to 100 times cheaper, where if you find something in development versus production, like you can use the analogy of it's a bug at the end of the day. And so finding a bug in development is so much cheaper than finding in production. And in this case, you have the added case where if it does happen in production, somebody's probably doing something pretty bad with it that has further costs and implications from news and other things like that. But that's all doom and gloom. It's just, it makes people happier and less bad things happen.
Yeah. Okay, so let's talk about compliance. So how does vulnerability scanning fit into compliance?
Yeah, so there's many different layers into this. I think the first and foremost, it's about having that process in place. So showing demonstratably that you are doing that scanning. It's baked in, but it's not just producing a report, but you're actually actioning on it. You're actually fixing it. And so if you look at all the standards like GDPR, ISO, PCI, all of them are essentially going down the road of you should be testing it as you are building your application. You should be fixing these issues. Having that set of tools and processes in place is a fundamental part of demonstrating compliance. And so that's, in my world, it's essentially make sure you have those tools in there, that you're scanning, somebody's actually looking at the results, and that they're actually being fixed. So that's a big part of it, but really important to go beyond just the minimum. You want to actually have it as a part of the DNA of what you're doing.
Yeah, absolutely. Yeah, and I think that ties back to what we talked about earlier about how, scanning is just one part of the overall process.
Absolutely.
Excellent. Okay, let's dive into implementation. So how do you get started with vulnerability scanning, or how do you implement it?
So the guidance that I usually give for folks that are just starting out with this type of scanning, or maybe you're just acquiring a different tool than you've used before, or maybe you've done one type of scanning versus another. I always treat it as you bring in the tool, and the first step that you want to do is get visibility. So understand how bad is the problem, and it might be great. Maybe you have been doing this type of testing before, but understand how bad the problem is. And so in our world, that just means connect it to your code repository, onboard your projects, and you'll get a report in a few minutes saying, here are all the issues. And so that's the first step, is understand the problem. The next step is to start prioritizing or essentially doing that initial triage, right?
Hmm.
If you've never done this kind of testing, the reality is you may find hundreds or thousands of
Yeah.
issues. And so the reality is you're not going to get that fixed overnight. So the idea is to prioritize which are the worst issues, which are the things with the highest risk, and task the development team with working on that. And then the rest you'll essentially backlog. The next step is essentially what we call prevention. So it's the idea that be enabling the development team to, again, through secure code training, providing tools to help them select packages and other things like that, providing the IDE tools, or maybe having a PR check where when they check in their code, it's being checked. And the idea is to prevent new vulnerabilities from getting in that code pipeline. And so that's essentially usually the first, let's say 30 days. Again, it's going to vary depending on the number of apps, size of company, but that's very critical. And then over time, you're going to work on the backlog. So essentially, you had all those things that you didn't fix in the initial triage. Just over time, through new development, through bug fixing, because you're checking that code before it goes out again, a lot of those older issues over time can be addressed. But we also have that capability where even when you're not working on the application, we can actually say, hey, you have these older issues you didn't address, but there are actually known fixes. We can actually drip fix suggestions to you in a number of different ways. And so essentially just think of it as the first 30 days is all about understanding like what's the problem and enabling them through tooling to make sure it's
Hmm.
not any worse. The other thing, which I also talk quite a bit about, is make sure when you introduce these tools that it's not seen as a disruptor. And what I mean by that is you don't want to just turn on a tool and suddenly everything breaks, because guess what's going to happen? You're going to end up with a very angry development team and nobody's going to trust the tooling that you bring in. And so what we often talk about is do passive monitoring to start. That doesn't mean you're not doing anything. But what it means is that the controls like breaking the build or blocking PRs are layered in over time, because the reality is if you were to start blocking day one, your code's going to stop and no, your business
Hmm.
isn't going to move forward. And so what you could do is allow them to check in the code, and in the meantime people have eyes on the results, and then can log tickets to get those issues fixed before it goes out into production and so on. So there's ways you can more passively check before doing that. And then let's say after 30 days, so the application's now in the state that's the steady state, that's when you start laying on controls to block PRs or block builds and so on. So having that agreement that, hey, just so you know, in 2 weeks we're going to start blocking things. So if any new issues get introduced, it won't be allowed to move forward. And so having those controls, and even the rules around how you do that, maybe you only block on, say, high and critical to start, or maybe only block if
Hmm.
there's actually a fix so you can do something about it. Maybe that's done at the beginning of the pipeline or at the end of the pipeline, like basically like your build. There's lots of controls you can layer in, but it's all about getting that trust, that buy-in, providing the guardrails, and every company's different on how they do it. But that's you want to slow roll it in that first 30 days to get that buy-in, to get that partnership. And it's going to vary if you're in a industry that's very compliance oriented versus, say, like
Hmm.
e-commerce or other industries. But that's the general guidance: is start with visibility, work on prevention, work through that backlog, and then slowly layer on the checks and balances and then the hard blockers, if that makes sense.
Yeah, absolutely. I think, slowly introducing it or rolling it in gives you an opportunity to also hone your internal processes as well, right? And, going back to what you were saying earlier, it's very important to be judicious about the blocking or high friction
Yep.
controls that you put in, because it can be very frustrating,
Yep.
especially if there is like a high false positive rate, right? There's,
Yeah.
as a developer, there's like nothing more frustrating than being blocked by something that isn't actually valid,
Yeah.
right? And so,
It,
yep, go for it.
and it's really important to state, just because we're not blocking doesn't mean that somebody doesn't have eyes on it. It doesn't mean you're actioning on it. It's just
Yes,
a
yeah.
more subtle way of doing it to start until people are acclimated to doing it. And often the way the companies will do that is they might turn it on for one or two of the key projects to start, and with a
Hmm.
stakeholder group, trial it out, figure out how that process works best in your environment, and then more widely roll it out. So but I think it's so important to state that even if you don't turn on the hard blockers, that doesn't mean that people don't have eyes on it. It doesn't mean that you're not actually actively acting on it. And that could be done through tickets, could be done through that core stakeholder work. a work group that's trialing the products. Hopefully that makes sense.
Yeah, yeah, absolutely. I do want to revisit or actually just restate a earlier concept you mentioned earlier about how when you first turn on these vulnerability scanning products, you're going to get a lot of findings, right? And um, I like how you mentioned that you can't fix all these overnight, right? And trying to boil the ocean and like fix these overnight is just is a futile task. But I think it's important to state that like this goes in, you need to prioritize and you need to start from somewhere, right? And so
Yeah.
starting from the highest critical vulnerabilities and moving that into remediation, that's where vulnerability scanning meets or feeds into the other processes. Okay, great. So we talked about how to integrate these scanning tools into your pipeline and your development lifecycle. Um, let's talk about when. Like, when should you scan, or when should these tools be running?
Yeah, so the short answer to that is continuously. But what does
Yes.
that actually mean? So, again, one of the things that we try to do is we try to implement it in as part of what the development's doing. So what that means is as code is changing, it's just happening automatically. And so, if I were to maybe start at the beginning, so when a developer is writing code, if the company is very proactive, the developers might be testing. You could write a line of code, or you can include a package and check it. The tools are there. It's optional. It's about enabling them. And so they may or may not be doing it. Some customers may automate that as whenever they go to check in their code, it'll be actually checking it there. So it's what we call a PR pull request check.
Hmm.
They don't have to do anything special. It just automatically happens as they're checking in their code. When they check it in, it triggers it. Snyk will actually automatically recheck every day to look for new vulnerabilities in their open source packages, or if they have containers, like the packages that they're including there. And the next step is like with each of your builds. So every time you do a build, that scan can happen seamlessly, and then we can notify them whenever there's a new issue. We have plugins and other things that you can integrate in as part of your development process. So it's just happening automatically, and all that data is feeding back up to Snyk, so you have reports and so on. So all of that's happening continuously, and the idea is as new issues come in, you're getting notified, and before that code can be checked in, there's a checkpoint to make sure that you're not introducing new issues. So you should never end up in that continuous triage process.
Hmm.
It should be, oh, a new issue was found, we fix it, and then we move on. And I think like all the automated processes are awesome because they're just included, they just happen. The developer themselves, that's going to be very cultural within the company. Well, do they check it every time they make a change? Do they check it at the end of the day? Do they check it in before they check in the code, or do they just rely on the PR check? Every company's culture is a little bit different, and especially if you're in crunch time as a developer, you're so focused on writing code, you're probably just going to check it as you're checking it in, or
Hmm.
unless you make a major change. It's going to really vary, I think, depending on who's using it.
Sure. Right on. Okay, so I guess to hammer a point here, um, when should you scan? You should continuously be scanning, right?
Yeah.
And the reason, or how this relates to actually implementation, is that perhaps this is the most important point. Uh, you can't just scan once and then and then you're done, right? You need to continuously scan because new vulnerabilities come up. You want to have very quick feedback cycles for the developers and just like integrate it into your pipeline, right? And so I think that that's a very important point to take away from the implementation side of the house with vulnerability scanning. Awesome. Okay, I think that's a wrap. So great. Thank you so much for your time today, Shawn. Thanks for everyone who is listening in. We hope that today's chat helped to demystify vulnerability scanning. You can learn more about security and compliance topics in the resources section of our website. You can subscribe to our channels for more content like this. And for customers that feel so inclined, we'd greatly appreciate any feedback you have for us on G2. We'll see you next time. Thanks.
Awesome. Thanks, everybody.